Hello everyone, thank you for being here today. My name is Mohit Mehta from Herr Germany. The study which I'm going to present today is a joint collaboration between DFE Pharma, Herr Hofliger and Hosokawa Micron. Topic for my today's presentation relates to understanding the impact of fines on flow behavior of lactose blends mixed with or without magnesium stearate and its impact on filling using membrane filling technology. If we look at the conventional DPI formulations, most of the DPI formulations had lactose as a single excipient, which was used as a carrier. However, if you look at the newer formulations, we have lactose as a carrier and another excipient such as magnesium stearate. Well, the magnesium stearate functionality, if you look at the functionality of magnesium stearate, in case of DPI formulation, it's rather diverse. It can be used as a stabilizer or a force controlling agent. When we add magnesium stearate in the API formulations, it can pose two major challenges. It changes the flowability of the formulation, which in turn can create a challenge while filling and especially filling the low amount of powders. With these challenges in mind, the study was designed to understand the influence of lactose with different coarse and fines ratios mixed with magnesium stearate and also to see the impact on the blend flow properties after adding magnesium stearate and also the impact on the filling behavior using membrane filling technology. Uh, we used LH206 as a coarse grade of lactose and with the three different fines, LH210, 230 and 300. If you look at 210, in case of 210 and LH230, we had the ratios, the fines ratios as 10%, 20 and 30%, while in case of LH300, the fines concentration was reduced to 2.5%, 7.5% and 12.5%. If you look at the process, as an initial step, the coarse and the fines were blended with Nota low shear blending, and these blends were then characterized for particle size and the flow properties using FT4 rheometer. And these blends were then further filled with SSP2 membrane filling technology. In the second step, the same pre-blends which were blended by a low shear blending with Nota, were further blended by adding 1% magnesium stearate on cyclomix high shear blending. And then these final blends were further characterized for powder characterizations for particle size and flow properties using FT4. And then these blends were further filled with membrane filling technology. If you look at the particle size characterization on the left hand side, we have we have plotted particles below 30 microns and different concentrations of fines. So on x-axis we have different concentrations of fines with 210, 230 and 300, and on the y-axis we have particles below 30 micron. In each and every case, we clearly see that as your fines concentration increases, there is an increase in the particles below 30 micron. This behavior was also seen when we added magnesium stearate to lactose preblends. On the right hand side graph, we have plotted D10. So on x-axis, we have D10, and on y-axis, we have different concentrations of 230 and 210. Here we try to compare plain pre-blended lactose with lactose blended with magnesium stearate. So in case of when you have low concentrations of fines with 90-10, we clearly see that the D10 value increases when you add magnesium stearate. This means that it shows a agglomeration effect when you have low concentrations of fines and when you add magnesium stearate. However, this this phenomena is kind of counterbalanced when you increase the fines concentration. So in case of 70-30, we clearly see that the values for D10 is nearly the same for lactose or plain pre-blend lactoses or lactose blended with magnesium stearate. This phenomena, I would say, is not clearly understood, but needs further investigation. Uh, Further, we tried to find a correlation between the particle size, compressibility, and mean fill weight. So on the left-hand side, we have plotted lactose particles below 30 micron and compressibility. And if you look at the correlations, we see a very good correlations between lactose particles below 30 micron and the compressibility values for these blends. For plain pre-blended lactoses as well as lactoses with magnesium stearate. In both the cases, the correlations were quite good. Uh, the other observation, what was seen was as you add magnesium stearate, the compressibility value decreases compared to plain pre-blend values. On the right hand side, we have plotted compressibility on x-axis, and on y-axis we have mean fill weight. And we again see a reasonable correlation when we look at plain pre-blend lactoses. However, the correlation decreases when we add magnesium stearate, and this was specifically due to this one particular batch having very high concentrations of fines and also magnesium stearate. This might have created an agglomeration effect and some void spaces, so the fill weight was rather low. But if we exclude this batch, then the correlation was around zero point 0.9. Overall, we can say that a good correlation was observed between lactose particle size 30 micron, compressibility, and the mean fill weight. In this slide, we presents again the correlation between particle size, permeability, and relative standard deviation. So on the left-hand side, we have we have plotted particles below 30 micron and permeability on y-axis. If we look at the lactose without magnesium stearate as well as with magnesium stearate, we again see a very good correlation. However, here in this case, when you add magnesium stearate, the permeability value increases compared to plain pre-blended lactoses. On the right hand side, we have plotted permeability and RSD for RSD, and if you we can clearly see that at a particular range of the permeability values, we have a very low RSD values. So if you have a permeability values typically more than 6 millibar, whether it is a case of whether it is plain pre-blended lactoses or lactoses with magnesium stearate, we see a very low RSDs. So in conclusion, we see a very strong relationship between lactose particle size below 30 micron, flow properties, and filling. Powder characteristics has a strong influence on the filling results, and addition of magnesium stearate significantly changes the powder flow behavior and hence has a substantial impact on filling. With this, I would like to end my presentation. And last but not the least, I would like to acknowledge my partners, Mr. Harry Peters from DFE Pharma, Dr. K.E. Moll from Hosokawa Micron, and Dr. Elke Stenberger from Hero Hofliger. If you have any further questions, do not hesitate to contact me on below email ID. Thank you so much for listening.